This is Radio TV Phono Nut, and what we have here is a Califone New Yorker from 1962. You can see the tag on it. This is, of course, a tube-type model, and it's been gone over. Amplifier rebuilt, new capacitors, new rectifier diode, new resistors is needed. Controls clean, new cartridge. Drive mechanism clean and lubricated, new power cord, and it works really well. This one uses a 50L6 output tube and a 12AT6 driver tube. Really wasn't wanting to get rid of this, but I've got an older New Yorker from '59 that I'll probably hang on to that one, but if I get rid of this one, the price is going to have to be right, or it's going to stay here. I'll give it a little demonstration.
Restored by Nio Marsh. Copyright 1966 by Nio Marsh Limited. Recorded for the Library of Congress in the Talking Book Studios of American Foundation for the Blind Incorporated, with the kind permission of the publishers Little, Brown and Company. Solely for the use of the blind.
Mariah blows the stars around and sends the clouds a-flying. Mariah makes the mountains sound like folks were up there dying. Keep on running.
As you can hear, this thing sounds quite good for a little school phonograph with a single-ended 50L6 amplifier in it, but that just goes to show when they put their mind to doing something, they can come up with a quality product. But like I said, I'm either going to get a good price for this or I'm going to keep it, because I'm really not that itching to sell it. But if the money's right, I'll let it go. It's kind of like a fellow that bought another record player from me told me. We were discussing prices, and he said, well, I look at it like this. I could have gone to the flea market and bought one that needed work, and he'd have probably paid anywhere from $25 to $50 for such a specimen. And then he said, assuming I could have found anybody to fix the thing, I would have probably paid as much, if not more, than what I paid for the one from you. And as we know, finding somebody that can properly work on this old stuff is getting hard to do. And if you can find somebody to work on it and do it right, it's not going to be cheap. And I don't blame them, because time is money, and the skills needed to fix this old stuff seems to be a dying art, so to speak. And the thing is, if you look on eBay, you see a lot of Crosley stuff that people don't mind paying $100+ for. And there are several other individuals that, in my opinion, do what I call hack restoration work. If you look at some of the pictures they provide, and if you read up on their reputation on the internet, and they'll sometimes paint the cabinet some gaudy, hideous, tacky color, but people pay them $300 and $400 for their crap. So, you know, the way I look at that, if people can go out and spend $100+ for a Crosley, or pay somebody $300, $400, $500, $600 or more for some botched up restoration on a record player, then they can pay me what I consider a fair price for this stuff, or it can just sit here.
Making a day, I called on my love after rain.
And also another thing to be considered is these old tube classroom record players are starting to become rare. 20 years ago they were all over the place, but now not so much, because most of the school systems that had them dumped them off decades ago when they were replaced with newer solid-state models, and this particular Califone is, in my experience, not an easy one to find. Over the past 30 years, I think I've had a total of 3 of these in my possession. 2 of them were local finds that once belonged to the local school system, but they were, let's just say, cosmetically challenged. That's a nice way of saying trashed. I ended up parting them out. That's how bad they were, but this one's in a lot better shape. This one was, it's got some scuffs and dings on it, but it's been pretty well taken care of. Alright, if you want this, there's a link in the description where you can get it. And if you choose to get it, then you ought to have you a nice little record player. Now moving on to today's repair project, we have this little Silvertone portable radio from probably about 1939. This runs on either AC or batteries. Case is in pretty good shape. The knob that's missing, it's broken and laying inside the cabinet. Here's the inside. It's basically just a 4-tube battery radio with the addition of a rectifier tube to allow it to operate on AC. Here's the power cord, which I won't know for definite until I pull the chassis, but this looks like a resistance line cord, which means it's a power cord with a resistance element wound in it, and the purpose for that is to drop the excess filament voltage across these 4 tubes here, or actually 5 tubes. I'll have to look and see. I don't think the rectifier will be in the series string. I'll have to look and see. I haven't really examined this yet, but let's get it out and see what the inside looks like. Alright, I'm clipped across the AC power plug with the switch turned on, and I'm getting it open, so there's no need to even plug this in because there's no continuity, which means a tube filament could be open, the dropping resistor could be open, or the power switch itself could be open. Yeah, you can see the resistance element wound around the wire on this that goes to this prong here, so yeah, this is a resistance line cord. And there's also a can-ohm resistor here. And as you can see, this is a very packed up radio, so I probably need to go dig up a schematic. That'll make it easier to figure this mess out. Now, I haven't dug up a schematic yet, but it looks like 35Z5 is wired in series with the rest of these tubes. And as I expected, the resistance portion of this power cord is wide open, so we'll just have to replace this cord with a conventional power cord and figure out what value of power resistor we can use in here. Alright, taking a break from the Silvertone, we're going to do an unboxing here. Using our professional unboxing tool. Let's see what we got here. I see the presence of bubble wrap and a few pieces of this stuff. Looks like your typical, well, maybe slightly better than your average eBay seller packing job, but not a whole lot. Well, looks like I see a Zenith radio here. And it It looks like I see a piece of busted Bakelite in the bottom of the box. That's never a good sign. And it looks like I see a radio that's busted to heck and back. You're probably wondering, why isn't he cussing and ever more throwing a fit about this? Well, it's because this particular radio has been pre-busted. All I want it for is the chassis to put inside of this cabinet that I've had for probably 25 years. I think this actually had a chassis in it when I got it, but it was so wrecked that there really wasn't much hope for it. So let's see what we've got here. They say this plays, and I see one cap here on the top side has been replaced. And the dial turns, but volume control turns, but I think the shaft is bent. As you can see, the cabinet, there's really nothing to do with that. Nothing busted there, busted along the bottom. They say this plays, so let's see what it does. Hang on. Alright, here we go. It's do or die. The dial light comes on.
Find out what hundreds of other repair improvements.
Well, yeah, it seems like our volume is turning down when I turn the tuning knob.
Karen, and I want it. Spence is at the top. Anybody having a tribulation? Guess what you're supposed to be doing?
Alright, it does work. Here's the underside of the chassis, not fully recapped. This looks like more of a deal where they just replaced just enough to get the radio to work reasonably well. But even that, I can't imagine them even doing that with a busted cabinet like this. So what I'm thinking probably happened is this cabinet was probably intact. They did just enough to get the radio going. They sold it on eBay. They did a sloppy packing job, like happens 99% of the time. The radio cabinet got busted, and then whoever bought it either got a refund and sold the radio for parts on eBay, or it got shipped back to the sender and they sold it for parts. But anyway, yeah, this will need a proper restoration, and it looks like they just spliced onto the original power cord with masking tape. But at least we have a chassis that's not botched up too bad that we can put in our good cabinet here. Okay, after all these years, we finally have a good chassis, good restorable chassis, made into a good cabinet, and this broken cabinet is going to someone on one of the antique radio groups who said he has one of these radios with some busted out louvers, and maybe he can cut out the louvers out of this cabinet and attach to his cabinet some sort of way. I know a lot of people are very good at mending broken Bakelite back together. I really don't happen to be one of those persons. Although on this one there's so much missing that there's really nothing to mend back together. Alright, that was just a little something extra. Now let's get back to the Silvertone. Okay, I just printed the schematic diagram, and the neutral side of the line goes to ground through the power switch. The hot side of the line comes along, and we have this across the line capacitor, which I'm not worried about. And then we come down through here, And here's our line cord resistor, also known as a curtain burner. The reason they were called that is because they got extremely hot, and they have been known to catch things on fire, especially if the power cord wasn't unwound. You know, if it was left bunched up and plugged in, it would get excessively hot and possibly catch something on fire. But anyway, we come down through this line cord resistor to one of the filament pins on the 35Z5, and the other filament pin goes to circuit ground. Now, where we're getting our filament voltage from, we have these 4 1.5 volt tubes wired in series, which require 6 volts to power them. And by the way, this uses a 6 volt A battery. Coming off the cathode, we have our B+, and then we have this humongous dropping resistor and filter capacitor here to give us our low voltage for the filaments when operated in AC mode. And that's what that big 10 ohm resistor is for, and there's a good possibility it's open, but the AC line cord resistors are more prone to open. Now, there's a few ways I could combat this problem. I could search around and find a new old stock resistance line cord, which would probably be difficult, and even if I found one, I wouldn't trust it because the insulation breaks down over time and they're just not safe, so scratch that idea. The second thing I could do is use Ohm's law to figure out what size of power resistor we could replace this with, and our 35Z5 draws 150 milliamp amps for the filament and requires 35 volts for the filament. So we take our line voltage, we'll just say 120 volts minus 35, that's 85 volts that we have to drop across here. So we need to know how many ohms of a resistor we need. So we take our 85 volts, it needs to be dropped, divide that times 0.15, and that gives us 666 ohms. That's not a good number. So I would choose a wire wound resistor with a value as close to that as possible. Now we need to know how much power of a resistor to get. How many wattage do we need? So we take our 85 volts, it needs to be dropped, multiply that times 0.15 amps, and that gives us 12.75 watts. Well, you're not going to get a resistor 12.75 watts, and even if you could, you don't want to go with one that's exactly the wattage of what you need. You want a margin of safety there, so I would probably go with a 20 watt resistor, 650 ohm if I could get one, or 680 ohm. I'd probably just go with a 680 ohm and 680 ohm 20 watt. But then there's a problem. We'd have to find a place on the chassis to mount it somewhere. And on this one, I think I could mount it over here on this side of the chassis, but then I'd have to run wires all the way over here to our rectifier tube. But then we're still going to have a heat producing resistor that's, it's really not necessary. Alright. The third way I could solve this problem is to come up with a 117Z6 rectifier tube that uses a 117 volt filament that could be operated directly off of the AC line with no dropping resistor. Might have to rewire the socket. I haven't looked at the pin out of a 117Z6, but we could do that and get rid of the dropping resistor. Well, I don't think I have any 117Z6s on hand, so that brings us to the fourth method I could use, and what I'm probably going to go with to solve this problem. We're going to eliminate the heat producing rectifier tube altogether We're going to eliminate this heat-producing dropping resistor altogether. And then we're going to take a 1N4007 diode and put it in series with a resistor. I don't know, probably 100, 150 ohms. That'll be a good starting point. And the reason we have to do that is because the silicon diode is much more efficient than this rectifier tube, and there will be much less voltage drop across the rectifier. And in a set like this, where you're powering low voltage tube filaments off of the B+ line, it's especially important that your B+ be within range, because if it's not, if it's too high, your filament voltage coming up here is going to be too high, and that could burn your tubes out, or at least shorten the life of them. See, I think that's what we're going to do. We're going to just change this tube out for a 1N4007 with a resistor in series with it, get rid of this drop-in resistor, and the advantages of that will be instant sound when you turn the radio on, because these battery tubes typically only take a second or two to warm up. And the second advantage is we'll be getting rid of these two heat-producing devices. These battery tubes don't produce enough heat to say you've got any, so once we make this modification, we should have a relatively cool running radio chassis. And if this 35Z5 is still good, and it probably is, we can use that in some of our 5-tube AC/DC radios and record players and such that use such a tube. And this tube doesn't appear to have a lot of hours on it. I don't see the usual burn off up here on the top that you see with a high hours tube, so this one's probably still good. So now I think what we're going to do is go find us an octal tube base, try to find an old dud tube here somewhere and break the glass off of it and use the base for our little rectifier module. Alright, we've got the radio plugged into a newer isolation transformer variable output job thingy here. It's going to take place of this thing that stopped working. Right now I'm using my lap as a place to set it. Running 120 volts input, I'm checking across the filament supply with a 15 ohm resistor ahead of the diode. I'm getting 5.5 volts and no activity from the radio. Now if those filter capacitors are bad, that could be affecting our reading too, so we're going to have to check on that. And once we make sure those caps are good, then we can probably take a more accurate reading. Okay, this 10 microfarad is open, 0.22 microfarad on the meter. That's the one in the middle right there. It's not part of the can. And then the 100 microfarad portion of the can on this end reads 150. Front, modern day 10 microfarad at 250 volts. Rear, 1941 version of a 10 microfarad, 75 volts. You can see the size difference from old to new here. Alright, this section here where the screwdriver is pointing is supposed to be 20. It reads about 15, so it's a little low. This one's 100. It's reading 150. And this one's 30, and it reads about 45. So I don't think this would... No, it's not shorted. It's not dried out, but it does read higher than normal and needs to be replaced anyway. So now we got to get it out of here, and then that should give us a lot of room to mount a terminal strip and put new capacitors in here. Okay, I replaced the across the line bomb cap and the power cord and the 55 ohm surge current limiting resistor for the rectifier. I didn't have a 55 ohm, I had a 47 ohm. That's good enough, and I found what I presume to be a wiring error. You notice here where they have the across the line capacitor before the 55 ohm resistor on the schematic, and the radio they actually had it going connected between the plate and circuit ground. Now, obviously it didn't really affect anything all for all these years. The radio, I'm sure, worked fine, but I reinstalled it. I installed it back to where it was based on where the schematic says it's supposed to go, and that's normally where they go anyway. Alright, with 120 volts input, I have my resistance box set until I measure 5.4, 5.5 volts. That's close enough to what the schematic calls for. Now, let's see what resistor we need. Alright, we now have 5.8 on the filament. Over here on the 10 microfarad cap, we've got 63, which is probably about right because that cap was rated at 75 volts. And coming off of the first filter, we have 120. That might be a little excessive, but we also have zero audio. No audio whatsoever. So, we need to look into that problem. If you've noticed here, I haven't done a bulk recap of this. We're doing this the old-fashioned way. We're troubleshooting the problem and fixing them as we find them. Once again, I'm afraid if I did a bulk recap of this and turned it on, I'd probably still be greeted with a silent radio. So, let's find out why it's silent. Alright, 3 is the plate on the first audio tube, 4 is the screen grid. Let's look and see what we got here. Plate voltage, got about 70 volts. At least we have something there. Screen voltage, what do we have? 73, that's good. Like I said, at least we have something there. Alright, where is the G1? It's buried under a capacitor, looks like. Alright, I heard a slight pop in the speaker when I placed my meter probe on the G1 terminal of the audio output tube, and I'm getting 5.8 volts positive there. That's not very impressive. Not impressive at all. You know, I had another silly moment. I was touching the grid cap of the IF tube when I thought I was touching the grid cap of the audio tube. As you can hear, we have audio, but still worried about that almost 6 volts on the control grid of the output tube. So let's snip out that capacitor and see if there's DC on the end of it. Alright, let's see what we have here, if I can get to it. Oh, Pernula. 33 volts on the other end of that capacitor, unloaded. So yeah, thing's leaky. Let's see how much what's on the plate side of it. 48 volts on the plate side. 34 volts on the other side, and it is dropping some, but yeah, that capacitor's finished. It's a 0.002 according to the schematic. Alright, there's the new cap, and I'm hearing a faint station come through, but before we tune across the dial, let's recheck our voltages here, starting with the control grid of the audio output tube. Let's see, is this it? I think so. What do we have? 0.03 volts, that's much better. Okay, what do we have on our filament line now? Yeah, about what we had before. Let me turn it up to the higher range. We're on the higher voltage section now. Alright, 64 volts there, and 120 there, so it didn't really affect the B plus voltages any. Now let's tune across the dial and see if I hear anything.
Your little boy, I don't know, but maybe he needs to be a man too. So I think he needs to step up beside you, and you guys make.
This tuning capacitor has junk in it, I believe. But at least we're picking up one station. That tells us that the
doesn't come home and buy some expensive item and go, look what I did. Isn't this wonderful? No, we make those decisions. Now, if I'm buying a boat or something like that, she probably doesn't give a rip.
But that tells us that all of our critical components are likely okay, as in IF transformers, oscillator coil, etc. Alright, I cleaned the tuning condenser by spraying some contact cleaner in it and rubbing a heavy piece of paper in between the plates to get all the gunk out.
A VIP tour guide at Disneyland. What they do is they...
It's still wanting to mess up a little bit.
With you all day. Here are your projects. Schedule your free estimate online at Certipro.com or call 800-GO-CERTA at Certipro.com or call 800-GO-CERTA.
Understand location.
Always a pleasure. Patrick Murphy, the head coach of the Crimson.
You might say no. It comes from...
Yeah, I'm still going to have to work on this tuning condenser some more, but...
You don't have to be the blistering pace. You don't have to be at the diesel intensity. I do want you to get your house paid off.
Alright, we can tell the sensitivity is good, so that tells us the front end's working as it should. We need to just concentrate on the audio stages to see if we can perk that up a little bit. No, this is not going to be as loud as a standard AC only operated set with a 50C5 or 50L6 or similar tube, but it should get louder than what it's getting. Found this capacitor. It's connected between the cathode, which is also the filament in this case, of the first audio tube and ground. It looks like some kind of early molded job, but I've never seen one shaped exactly like this. There's no value printed on it whatsoever. The schematic says 0.22 microfarad. It makes absolutely no difference whether it's in or out of circuit, so it must be, I don't know, might as well just go ahead and replace it.
Allowance to spend.
Alright, I'll replace the...
Not in that book, yeah. That was not...
I'll replace the spring grid bypass cap for the audio output tube. And I'll replace this 0.05 cap here that connects between the bottom of the IF transformer, first IF transformer, and the cathode of the IF amp tube, and getting those two caps replaced seemed to help, so I might as well just go ahead and change the rest of these out and be done with it. Okay, got all the capacitors replaced, and it's a lot louder now. Still going to have to play with this tuning condenser. It's cutting in and out, especially at the lower end, but I'm getting tired of fooling with this today, so we'll come back tomorrow or whenever and do a few other little things to this, and then it should be ready to go. Okay, I've got it all back together.
Changed. You were global, you were a superstar, and you just couldn't go out and hang out and have a beer with...
I cleaned the heck out of the tuning condenser and got it working better. I need to find a replacement knob for this tuning knob to replace the broken one that's inside the radio, or maybe I'll fix the other one, I don't know.
I went to New York with the old WWE.
Right.
Wrestled Andre Shea Stadium.
You can tell the gospel station has the modulation cranked way up.
I wish I could get the message over to you.
That station sounds like crap.
This will be bigger. I really do. I'll just put it this way, and let me give a head up. Just like everybody needs a pillow, everybody's going to need multiple.
On the EIB network.
And by the way, this radio was made by Detrola for Sears Roebuck, based on the 109 chassis number prefix.
A slowdown in manufacturing. We've seen some data on that.
All right, there you go.
We see a slowdown in services.
Another one saved.
We're not yet near a recession. For example, the ISM non-manufacturing index came in at 52.6, lower but still reflecting economic growth. Such data illustrates why we guide clients.
You can read about the mission. You can read about what's going into my store. And I love Mike Lindell's message of hope. If you don't mind. The people freaked out, but they saw Hollywood Hogan and how cool I was, and the bad guy thing. They